Hello everybody, welcome to our second video on 2.2, statements and conditionals. We're going to talk about, as you can see highlighted by that green arrow, that we're going to write and determine the truth values of conditional statements. And I'm going to add right below there, which you don't need to write this down anywhere, there are 4 types of conditional statements. One of them being conditional, converse, inverse, and a contrapositive. So 4 terms, fairly hard to remember, but they are connected in various different ways, which we'll see here in just a moment. Alright, so let's go ahead and take a look at the first 2 key ideas before we talk about any kind of conditional statements, and that is hypothesis, my goodness, and a conclusion. So if we take a look at the hypothesis, this is a connection we're making from science. So we're drawing some kind of hypothesis and then drawing a connection from history or from literature and how to draw an effective conclusion. But in math, it's much easier because a conditional statement is a fancy way to say an if-then statement, which you'll hear me refer to that quite often. And the hypothesis, I can't say that word. The hypothesis is the statement after if. Right? So the hypothesis is just the statement that comes after. If this happens, and if you haven't already been able to make the connection what we're going to next, the conclusion, the statement, and end there, apologize, after then. So if said thing happens, then this conclusion can be drawn. So an if-then statement. Anybody who's done science fair, any kind of science experiment, this is how you're writing. This is the language you're using. If this happens in my experiment, then this is the result I expect. It's the same thing we talk about logic and conditional statements. So let's look then at what we're referring to when we talk about these P and Q. Where did P and Q come from? So on the side here you have a little bit of space. I want you to write down that a P is the hypothesis. So when we talk about P, we're referring to the hypothesis, and Q refers to our conclusion. So it's just some fancy math lingo. We use P and Q. We could really have picked any letter, but P and Q are the ones that have been chosen to use. And you'll see that over in the next 4 examples we use P and Q. Okay, so the conditional, and I'm going to add here below, I'm going to write, it's the OG, right? It's the original, I guess you would say it's the original gangster, but it's the original statement, the conditional. That's where everything begins. That's what we use to write the next 3. So if we're saying if P then Q, we're really saying if the hypothesis, comma, then the conclusion. And again, just putting that into words. What does the P and Q mean? If the hypothesis occurs, then this conclusion is to be expected. So let's write an example, and I'm actually going to type this for the sake of it being a little bit cleaner. Let me go and insert a text box and put that down here. So if we're looking at this statement, this is what we want to have written down. So if the battery dies, I'm referring to a cell phone, then your phone will shut down. So we're looking at that statement there. It says, if the battery dies, then your phone will shut down. So my hypothesis is if the battery is dead, the conclusion is the phone will shut down. So that again is the original statement, that's the conditional. If we go over to the converse, right, we're just switching the conditional. We're saying, what about, writing this down at the bottom here, if the conclusion happens, then the hypotenuse. So if the conclusion happens, then the hypotenuse will happen. So we're swapping them. Hard language to make sense of. Let's see this same exact example played out again. So let me go ahead and insert another text box. So if I insert another text, we can say that if the phone shuts down, then the battery is dead. So if the phone shuts down, then the battery is dead. So let's take a minute here. We didn't do this for the first one. Are these statements true? Can we give them a truth value? Let's take a look at the conditional. If the battery dies, then the phone will shut down. And that's going to be true. Because when the phone turns off, If there's no battery left, the phone is going to die. It won't continue to work without the battery. But if the phone shuts down, then the battery is dead? Does that have to be an accurate conclusion? And we can say, I'm going to put false because I found a counterexample that works. And in this case, that's when I manually shut phone down. I can do that by myself. I can turn my phone down on my own. So again, looking at the difference between the two, if the phone shuts down and the battery is dead, that can have a counterexample when I do it by myself. But if the battery is dead, the phone is indeed going to shut down. So again, the conditional in this case is true, and we found a counterexample to make the converse false. So let's take a look at two more examples here before you go to the back, which is a whole table of examples for you to try. So, inverse and contrapositive. So inverse, we're going to go ahead and put some vocabulary here. This is the exact opposite of the conditional. You can squeeze all that in there. The opposite, of the conditional. And that's what the inverse is. And if you already can guess what the contrapositive is, it connects to the thing that's directly above it. So this symbol right here, this symbol is called the negation, right? Negation, or to negate, or to make something not itself. So in this case, we're saying if not hypotenuse, again abbreviating, then not the conclusion. So if not hypotenuse, if then not the conclusion. So we're taking the exact same statement from before and putting not. And I'm actually going to go back and go ahead and copy this text and go ahead and paste it and just literally add the word not while you write yours in as well. So let me give me a second to pull this up. So if the battery does not die, does capital not die, then the phone will not shut down. Oops, not shut down. So if the battery does not die, then the phone will not shut down. I can use the same idea we did for the last one to come up with a counterexample as to why this would be false. So we're going to go ahead and put the word false and then think of a counterexample. So the battery's not dead, then your phone's not going to shut down. But again, we can manually shut our phone down even if our battery is not dead. Right? So our battery could be at 80%, but I could manually shut the phone down, and therefore the phone will turn off, right? So again, manually being able to do this, whether the battery is dead or it's not dead, is going to be able to make these statements false, because that is our counterexample. And then finally, I'm going to go back and go ahead and copy and paste that again as a converse statement. And our converse statement is again the exact opposite of our inverse, which again is switching the place of what the hypothesis and the conclusion are. So if the phone does, let's write this down, the phone does not shut down, then the battery is not dead. So again, let's read that one more time. If the phone does not shut down, then the battery is not dead. The phone does not, so if the phone stays on, then the battery is not dead. And that's absolutely true. So we can put this as a truth value, which is true. So again, unless you can find a counterexample to disprove that, this is going to be a true statement. So you're thinking of counterexamples that go with it. If you cannot have one, therefore we can determine that it is true. So go ahead and flip it over to that last page. We're going to give you a minute to pause the screen and come back to it. And then you're going to end up doing this entire back part on your own before our class tomorrow, just to get some practice with those topics. But this first one says, for the conditional statement below, write the converse, inverse, and contrapositive, then determine the truth value. I also want to add, if, you don't have to write this down, but just so you know what to do, if false, provide counterexample. So if you determine them to be false, provide a counterexample to show me why you determined it to be false. So again, I'm going to read the conditional, pause the screen, come back, we'll go over those three answers. So if you live in New Jersey, then you live on the East Coast. So let's determine first if that's true or false before you try the other three. Again, if you live in New Jersey, which we can already agree is on the East Coast, then you live on the East Coast. So knowing that New Jersey is on the East Coast, this is therefore a true statement because New Jersey is on the East Coast, and then it's saying if you live there, then you live on the East Coast. Okay, again, pause the video. When you come back, you'll see the converse and then a statement, and I still want you to come up with your own counterexample if you see one of these or more than one of them to be false. All right, go ahead and pause it. We'll be right back. Okay, so on the screen you're going to get a chance to see each of the three statements being rewritten from the conditional statement and their truth value. So again, the converse, if you live on the East Coast, then you live in New Jersey. That is indeed a false statement, because you could live in New York, you could live in Delaware, you could live in Virginia. Any of those places are on the East Coast, and they're not in New Jersey. So that is a false statement. So any of those work as a counterexample. The next one is the inverse. If you don't live in New Jersey, then you don't live on the East Coast. And we could use the same argument we did from the converse to come up with a counterexample. That just because I don't live in New Jersey and I live in New York doesn't mean I'm not on the East Coast, because New York is on the East Coast. So that is also, it's not New Jersey, but it is on the East Coast, which makes that inverse false. And lastly, the contrapositive, if you don't live on the East Coast, then you don't live in New Jersey. All right, well, let's think about it. Come up with a place that's not East Coast. Let's go with California. It's on the West Coast. That's not New York. You could come up with Indiana. That's not on the East Coast. It's also not New York. Any example you can think of that's not on the East Coast is also not New Jersey. So any of those examples work. I apologize. I think I said New York before, but it is New Jersey. So the conditional and the contrapositive are true. All the things in between, converse, inverse, are false. Again, the last thing I want to highlight before we go here is to fill out this table with the three geometric ideas we've talked about. And if you have a counterexample, provide one. If they're all true, you don't need a counterexample. But make sure you go through and look at all 9 scenarios, whether they're true or they're false. Okay, hope this helps. Again, review it if you need to go over it. You've got each of these pieces of information to go with it. The only thing you don't need to write down was the objectives at the beginning. Thanks, everybody. Talk to you soon. Bye-bye.